Welcome guys. So we have this equation here that says the roots of the equation 3x squared plus 4x minus 5 equal to 0 are alpha and beta. Find the equation with integer coefficients whose roots are, we have 1 over alpha and 1 over beta, beta squared plus beta squared, and so on and so forth there. Now, for example, if we have two roots here as solutions of an equation, or if we have two answers as solutions of an equation, let's say the first root is R1 here, and the second root is R2 here. Now, here we know that if this is the case here, then the new equation that can be formed using these two roots that we have here can just be written as follows. We have x squared minus, open brackets, we get the sum of these two roots here, R1 plus R2 here, that is the sum that we have, plus the product of this here, which is R1 by R2 here, equal to 0 like this here. So meaning that here, the equation that we're going to use to answer everything that is below here is simply just equal to x squared minus the product, or the sum rather, sorry, let me just erase that, minus the sum of the roots that we have multiplied by x plus the product of the roots that we have equal to 0 here. Okay, so this is the expression that we're going to use throughout to answer everything that we have below here. Now, when you look at the first question that we have here, you'll notice one thing that we have there is our R1 is, or the first root that we have there, let's name it R1, it's simply equal to 1 over alpha, and our R2 in that case is simply equal to 1 over beta like this here. Then we have an equation in question there, which is 3x squared plus 4x minus 5 equal to 0 here. Now, we need one thing here that we need to know here. We know that the sum of the two roots here is simply equal to negative b over a, and the product of the two roots is simply equal to c over a like this here. So meaning that here, the sum here is going to be negative 4 over 3, then the product is going to be equal to negative 5 over 3 like this here. Okay, so now this simply tells us that everywhere we're going to get alpha plus beta, we're going to substitute with negative 4 over 3. Everywhere we're going to get alpha beta, we're going to substitute with negative 5 over 3. Okay, so now that we've gotten this out of the way, let's start answering the question that we have here. So A, we have the two roots that we have 1 over alpha and 1 over beta like this here. Now remember we said we're going to use this formula here where we have x squared minus the sum multiplied by x plus the product of the two roots there equal to 0 here. So I have our x squared minus the sum of the two roots that we have. The first root that we have is 1 over alpha plus 1 over beta x plus the product alpha, or 1 over alpha, sorry, 1 over alpha times 1 over beta like this here equal to 0 there. So we proceed. We have our x squared minus, then here on the middle here, our common denominator here is going to be alpha beta. So alpha into alpha beta will remain with beta here, plus beta into this will remain with alpha by 1. We just have alpha. We have x plus, open brackets, then this side we have 1 over alpha beta like this here. This here equal to 0 now. Now remember, here we have alpha plus beta here, which is equal to negative 3 or negative 4 over 3, and we have alpha beta, which is equal to negative 5 over 3 here, like this. So meaning that here we can just write this in this way. So we have x squared minus alpha plus beta, everything divided by alpha beta, x plus 1 over alpha beta here equal to 0 here. So we're going to substitute in everything that we have here using the figures that we have this side here. So meaning that here we're going to have x squared minus, open brackets, negative 4 over 3 divided by negative 5 over 3 here. Then we have x plus 1 divided by negative 5 over 3 equal to 0 here. Then when we change this division symbol here into multiplication, we're going to have x squared minus negative 4 over 3 multiplied by negative 5 over 3, or negative 3 over 5, negative 3 over 5. So let me just erase that. We have negative 3 over 5 x plus, then this side we do the same thing. This is going to be 1 multiplied by negative 3 over 5, close, equal to 0 this side here. So just trying to come up with the equation there. So negative times negative, we get a positive. So 3 and 3 will cancel there. Then we have x squared minus 4 over 5 x plus, or that's going to be negative there, minus here 3 over 5 equal to 0 here. So now to get rid of these fractions here, we can just multiply this whole equation that we have by 5. We're going to have 5x squared minus 4x minus 3 equal to 0 like this here. So this is the first equation that we can make using those two roots there. Okay, so let's look at the next question that follows. Right, so we go to the second part. So let me just erase what we have here. Okay, so we go to B. We've solved A there. So B, the two roots that we have is alpha squared and also beta squared here. Now we use the same equation that we have this side, which is x squared minus the sum. Minus the sum there. We multiply it by x. So we multiply the sum by x plus the product of the two roots equal to 0 percent here. Now, here we're going to have x here squared minus the sum. We have alpha squared plus beta squared here, and then it's being multiplied by x plus the product of alpha squared multiplied by beta squared here equal to 0 here. Now, when you look at the sum that we have here, we have alpha squared plus beta squared here. This is an identity here. Okay, so let's derive the identity that we're going to use for this here. Now, if we get alpha plus beta, the sum, if we square it, we're going to have alpha plus beta and also alpha plus beta this side here. Then when we multiply alpha times beta or alpha times alpha, we're going to get alpha squared. Alpha times beta here, we're going to get alpha beta. Beta times alpha, we get alpha beta here. Beta times beta here, we're going to get beta squared. Now, remember, this side we have alpha plus beta squared like this. So then, here, we're simply going to have alpha plus beta squared equal to alpha squared plus the squared that we have here will be beta squared as well. Then these two here, alpha beta and alpha beta, are two like terms, so you can just simply add them. We're going to say plus 2 alpha beta like this. Now bear in mind to say that in the equation that we have alpha plus beta, which is what we are looking for there. So meaning that we can just simply make alpha beta the subject. We push this negative, this 2 alpha beta the other side. Then we're going to have alpha plus beta squared minus 2 alpha beta is equal to alpha squared plus beta squared like this here. So meaning that where we have alpha squared plus beta squared, we're going to substitute with this identity that we have here. So therefore here, this equation becomes x squared minus, open brackets, alpha plus beta squared minus 2 alpha beta. We close here, everything is being multiplied by x, plus, then here, this is the same as alpha beta squared equal to 0 like this here. Now, we have alpha plus beta, we also have alpha beta and alpha beta this side. We have their values here on top, so what we can just simply do there is, where there's alpha plus beta, we substitute with that, and where there's alpha beta, we substitute with that there. Then we have x squared minus, open brackets, alpha plus beta. The value of alpha plus beta is negative 4 over 3, so we have negative 4 over 3 here, squared minus 2 multiplied by negative 5 over 3. We close here, we have an x there, plus alpha beta, we have negative 5 over 3 squared equal to 0 here. Then we have x squared minus, open brackets, so negative 4 squared, we're going to have negative 16 over 9, or 16 over 9, then negative times negative, positive, so plus 10 over 3 like this here. We have x there, plus, so negative 5 squared, we get 25 divided by 9 equal to 0 here. We simplify this equation further. We have x squared minus, then what's in the brackets here? The common denominator here is 9. The 9 into 9, 1 times 16, 16 plus 3 here, 3 times 10 here. We're going to get 30 like this. Then we have x here plus 25 over 9 equal to 0 here. Then we continue. We have x squared minus, open brackets, so this is going to be 46 over 9 multiplied by x plus 25 over 9 equal to 0 here. Now, this equation is the same as negative 46x over 9 plus 25 over 9 equal to 0. So to get rid of the fractions that we have, we can just multiply this whole equation by 9. Then we're going to have 9x squared minus 46x plus 25 equal to 0 there. So that is the new equation that we can form using those two roots that we've been given there. Right, let's go to C. Okay, so we do the same thing for C. So see here we have the two roots that we have alpha plus 1, and also we have beta plus 1 here. So bear in mind to say we'll just be using the same equation that we have there. So where we have x squared plus the sum multiplied by x plus the product of the two roots equal to 0 here. So then here, also this is supposed to be a negative there, sorry. Okay, so minus here. So we have x squared minus, open brackets, we get the sum of the two roots that we have, which is alpha plus 1 plus beta plus 1 here. We close, multiplied by x plus the product of the two now, where we have alpha plus 1 and also beta plus 1 equal to 0 here. Then here we have x squared minus, open brackets, we're going to have alpha plus beta plus 1 plus 1, we're going to get a 2 here. We close, we have an x here plus. Then when we expand the brackets that we have this side, we're going to have alpha beta plus alpha plus beta plus 1 equal to 0 here. Now, you'll notice to say that we have the value of alpha plus beta here, and also we have alpha plus beta here. So mean that where there are these two here, alpha plus beta and alpha plus beta, we substitute with the values that we have there. Then where there's alpha beta, we substitute with that value there. So mean that here we have x squared minus, open brackets, negative 4 over 3 plus 2. We close, we have an x here, plus we have negative 5 over 3, like this here, then plus negative 4 over 3 plus 1 equal to 0. Okay, we make this a single fraction here. We're going to have x squared minus, open brackets, our common denominator here is going to be 3 here. So 3 into 3, 1, 3 by negative 4, we get negative, or 1 by negative 4, we get negative 4. Then 1 into 3, we get it 3 times 2, we get plus 6 here. We have an x here, plus k. So this side here, so this is supposed to be minus 5 over 3 minus 4 over 3 plus 1 equal to 0 here. Then we have x squared minus negative 4 plus 6, we get a 2x. So we're going to have 2x over 3 minus, then this side here we have the common denominator that is going to be 3. So I say everything here divided by 3. 3 into 3, 1 by negative 5. We get a negative 5 here. So let me just say plus here. So I get a negative 5. Then here we get a negative 4. Then plus 3 equal to 0 here. Then we have x squared minus 2x over 3. Then negative 9 plus 3, we're going to get negative 6. Then negative 6 divided by 3, we get negative 2. So here we're going to have minus 2 equal to 0 here. So now, since we have a fraction here, to get rid of this fraction here, we can just multiply throughout by 3. Then we're going to have 3 x squared minus 2x minus 6 is equal to 0 like this here. So that's the new equation that can be formed using those two equations that we have there. Okay, let's go to the next one. Should be D there. So on D, we have alpha squared beta, and we also have alpha beta squared like this here. Remember, we're still going to be using the same expression that we have this side. So here, x squared minus the sum of the two roots multiplied by x plus the product of the two roots equal to 0 here. Then we have x squared minus the sum now. We add these two roots that we have there. So we have alpha squared beta plus alpha beta squared. We close. We have x here plus the product here we're going to say we have alpha squared beta multiplied by alpha beta squared equal to 0 here. So now let's try to simplify what we have in the brackets here. So we have x squared minus open brackets. Here we have alpha beta which is common in the two terms, so mean that if we factor out alpha beta on each and every term that we have here, here we're going to remain with alpha plus, in this side we're going to remain with beta here. We close, and then we close everything again here, multiplied by x plus alpha squared times alpha here, we're going to get alpha cubed. Beta times beta squared, we're going to get beta cubed equal to 0 here. Okay, so now we have x squared minus open brackets alpha beta, alpha plus beta multiplied by x plus alpha beta, the power 3, since they all share the same power there, so I can just put them together in the brackets and then we sub the values there. So now we can substitute in the values here, since we have the value of alpha beta this side, we also have the value of alpha plus beta here. So then we have x squared minus open brackets, where there's alpha beta, we put our negative 5 over 3, open brackets, alpha plus beta, negative 4 over 3, we close here, we have x plus open brackets, negative 5 over 3 square cubed like this. So these substitutions that we've made here, they come from the sum and the product of the roots that we have here. So here we have x squared minus open brackets here. If we expand here, so this will be 3 times 3, we get 9 below there. Okay, let me just erase and write everything nicely. Okay, so we have x squared minus open brackets, we have below there we're going to have 9, then negative 5 times negative 4, we get a 20, we close, we have our x here, so that's going to be negative, because when you raise a negative number 3 times, we get a negative value there. Okay, so negative 5 to the power 3, we get negative 125 divided by 27 here. So now here equal to 0. So if we multiply by 27 throughout, we're going to get we need to get rid of the fractions here, so we're going to multiply by 27 throughout. We're going to have 27 x squared minus, so 9 can go into 27 3 times, so we're going to have 60x like this, minus 125, so this should be 60x minus 125 equal to 0 here. Okay, let me just write that nicely there. So minus 60x minus 125 equal to 0 here. Alright, so we can do the same procedure for all the questions that we have here. So the remaining ones, we have this here that they are in that expression that we have there. So you can just do the same thing. You substitute whether the sum, you add the 2, and then for the product, you also